just to recap about the projections. And we will be going through the classical from my blog post and from my example domain, so shopping cart. I think that it's simple enough to just grab what it is about, but it doesn't matter much because we will be focusing on the mechanics. So the shopping cart can have 4 or even 5 events. So at first, shopping cart can be opened. Then we can add some products to the shopping cart, maybe remove if we don't want to buy them. And then we need to confirm the shopping cart. And after that, the ordering process would normally start. We can also, of course, cancel what we had in shopping cart. There are some rules, but we won't be focusing today on the business logic, but more around the sorry, I will close the doc. Yeah, more around the projections, so read models part. And I highly encourage, if you didn't do that, to read my article, The Guide to Projections, because it gives the basic stuff and basic things that would help to understand that. But let's do a short recap around projections. So projections are different interpretation of the same information, of the same facts. So I like to show this picture because it shows that the same fact, so the ending of the boxing fight, can be interpreted totally differently by the winner and by the loser, in this case, Muhammad Ali and Sonny Liston. And what's more interesting about this photo is that the audience also interpreted that differently. The fact that fight was finished, till this day, some people argue whether that was a rigged fight or it was a real fight. And projections going to our technology are usually used to build read models, and so they don't have to be used in an event sourcing context. I'll be using EventStoreDB today, but what I'm going to show you and explain, you can use the same patterns even if you are not doing event sourcing. If you are doing event-driven architecture, so using messaging tooling like Kafka, Rabbit, etc., you can do the same. So projections take some set of events. It can be one by one, it can be by batching, and then the most popular way is to handle projections using the left fold approach. So left fold means that we are taking event from the left side and we are folding it, so updating the state of our read model. So we are typically taking the current state and then updating it or inserting or doing some data manipulation. So here, if we got the cart open event, so initialized, then normally we would create a new record, a new read model. Then if we are getting the follow-up event, so for example, product item was added, then we are either updating some field or we could even append that to some additional collection, like a nested list of product items. And then after we do that, then we can use it to query informations, etc. And the specific thing about the projection is that, as I mentioned, the same event can be interpreted totally differently. So, for example, product added will update the product's availability. It will update the shopping cart details and, for example, some dashboard or some other views. And projections technically can also be resulting with the additional events because it's not set where we should be storing those results of the projections. Technically, we can use projection to generate also files like PDFs, etc. Projections can be also synchronous. They don't need to have eventual consistency. So for example, if you are, you can wrap, if you are using event sourcing, then you could wrap the event append and projection applied within the same transaction, and then either event is appended and read model is also updated in the same transaction, or nothing has changed. And in most of the tooling, so like Event Store DB that I will be using, and stuff like Kafka, Rabbit, and other messaging tooling, then you need to deal with asynchronous processing and some additional latency, etc. The reason why it is like that is to make it more scalable, more fault tolerant, because of additional retries if something was wrong, and so on and so forth. So today I selected to use Event Store DB and MongoDB because they have the ROER API and the biggest permutation of stuff that you need to handle on your own, and the stuff that that requires your attention. So let's go to the code. So I will be using the TypeScript and Node.js because I like it, but it doesn't matter much. So I hope that you will be able to also understand the syntax. If something wasn't clear, then feel free to interrupt me and stop me. So this is a simple application. It has the simple API, so we can get shopping cart details. We can do all the actions that you saw. So we can open shopping cart, add product, remove product, etc. I won't be showing the details of how to handle that and how those events are produced. Let's just assume that there is some logic that in the end is appending an event into the event store. So this is our simple application. So this is how the asynchronous code and background worker could look like. In .NET, you would probably use the hosted service. In Java, there is a lifetime in Spring, a smart lifetime. So depending on your favorite dev environment, then you will need to use some background worker. And so here I'm subscribing to Event Store, and then I have two methods. One is to load checkpoints from the collection, and the other is to store checkpoints. And let's have a look what are the checkpoints and how the subscription look like. Let me go again to the slides, and let's discuss how the event stores, but also the like Kafka, etc. works. So when we are appending new message, then we are appending new event in the end, and each event will have its own unique monotonic number. And if we are thinking about that, then typically this append-only log will contain all the information, so all the events that were appended. Typically for event store, so event store DB and Marten and other, you have the guarantee of the global ordering. So you can see and have this global numbering and know precisely what has happened during our application lifetime. And then logically, those events are grouped into the streams. So this event 1 to 4 will be also having its own numeration within the specific stream, because we need to know what's the specific order in which events were appended to the specific stream. So in this case, user 129 will have 3 events. Then those 2 events will be from invoice, and the rest will be like in the user. And within the streams in event sourcing, there is a guarantee in majority of stores, or almost all stores that I know, that this numbering will be gapless. So you will have 1, 2, 3, 1, 2, etc. Because it's crucial to be able to rebuild the state from event, because you need to know what was the order of appearance. So if we look again from the different angle, then stream is some sort of index that is keeping all the events and one by one. And we also have this global order that is maintaining the logic of how those events were appended in the global order. So in fact, we have 2 types of numbering. So one is the global one, and as you can see in even StoreDB and in Marten and in most of them, this global numbering may have gaps. We don't know whether this will be a numeric value that will be 101, then 102. The only thing that we know about this global position is that it's monotonic, and each event will have its unique number. So there won't be 2 events with the same number, with the same position. And within the stream, we have also numbering, but that is specific for the specific stream. And this numbering is guaranteed to be monotonic and gapless. So are there questions to these positions? Because this is quite important. Should I explain it a bit more or elaborate on that? Can at least someone say something, because there is some so much technical issues, then I rather be sure that at least I'm being heard.
Oscar, it makes sense. The questions I have it's probably a bit early for me to ask them. And it's really to do with the requirement for the global clock. So I'm happy to come back to that later. So, but everything you've said so far makes sense to me at least. Okay,
thank you. So if we are not using Event Store, but for example, Kafka, then within partition, there is offset, and this offset within partition is also guaranteed to be monotonic, and I think that it might have gaps. So this would be more like a set of all streams within, so each partition will have its own numbering. But yeah, and those positions are quite critical to handle the read models, because as we are running that in some sort of application, then the process of this application may just crash, randomly die, etc. And then we wouldn't like to start always from the beginning and needing to process all of the messages that were registered from the beginning, from the starting point where the first event was appended. So then we need to maintain the position of last processed events. So for example, if everything was going smoothly, then we handle this event, then the next one, then the next one, and 200. And then the process crashed, database crashed, there was some other transient error that caused us to fail. Then if we are restarting the subscriptions, then we need to know that this event was the last one that we processed. So we can say to our messaging tooling that give me all the events that happened after this one. So we are claiming that we know this one, so give me another one. So instead of going from the beginning. And then we can do that by using, we need to store those checkpoints somewhere. And in Event Store, the most suggested and recommended way is to use the regular subscriptions, so-called catch-up subscriptions. And then, in this case, we need to maintain the checkpoints on our own. So we need to store them somewhere, and that's why we are passing. That's why we are passing the methods like load checkpoint from collection, because as we are our end read model is the MongoDB, then it would be best to keep those positions near or in the same type of storage as we have our read models, because then it's easier to handle operations. But of course, you can use any other types of storage. You can even store this checkpoint as another event within the event store. But at least in Event Store DB, you need to handle that on your own. And that's also the reason why I selected Event Store DB, to show you what's happening also in other storages, or in other messaging tooling, because some of them are handling that internally, but some, like Event Store DB, require you to do that. So the first thing that we will do is to load checkpoint, and checkpoint is just position, so the number, so the last position of the processed event. And then if this position is empty, then we are saying start from beginning. So give me all events, because I haven't subscribed yet. And then if we are, if we know the position, then we are saying, give me all events from this specific position. And then we can say Event Store DB to subscribe and to give us all the events. And Event Store DB give us possibility to subscribe to all events and also apply some filtering. Like here, I'm excluding the system events. And we can also subscribe to specific stream. In different tooling, it's differently, but yeah. So let's say that we want to get all the events. And here we are saying we need to provide the callback function. So this is this function that will be running the business logic, because subscription can be also used to do other stuff than read models. We could, for example, use it to send emails or integrate different services, etc. That's also the reason why I'm pushing here a list of event handlers. An event handler is just a method that takes event and does something with it, whatever that is. And after we run all the handlers that we have for this event, then if everything went right, then we need to store the checkpoint. So we need to say that, yeah, this is the event. I acknowledge that this event was processed. And then, so in our case, storing that will mean that we are just, let me find it. So in our case, it means that we are just updating some arbitrary document that has ID with the subscription ID. And it's, as you see, just setting the position to the one we provided. So nothing fancy. So again, we are subscribing, we are telling from which position we want to subscribe. And then once we got event, then we are running some handlers, and then we need to store the checkpoint. So is it clear, or should I explain it more in more details?
I have a question. handling idempotency is up to the handler.
Yes, that's correct.
Yeah.
Because handler knows the context of the handling, and I will be also showing this idempotency, how to handle that.
Okay.
But yeah, in general, I would suggest to start with handling idempotency on the handler, because they know context, and it's much easier and less fragile than providing the global idempotency check. Of course, we could do it also, try to do it, but for sure, I would not recommend to try to handle idempotency on the producer side, because still, because of the retries in the messaging tooling, you still can get duplicates more than once. For example, if we handled and updated read model, and then the process died and we didn't store the checkpoint, and we restarting the project, the subscription, then again, we will have the same event run twice. So even because of that, we need to assume that there is at least once delivery, not exactly once, even if some tooling is claiming that they provide such.
Okay.
Other questions? Okay, so I will ask myself, or you, why do you think then, why even StoreDB provided give the option or even almost force to use your own checkpointing? Why is it done like that?
I was actually surprised that it didn't. I assumed that it did handle that stuff for you.
Mm-hmm. So what could be the reason why they give that option here? Any ideas?
Separation of concerns and a potential bottleneck that gets created.
Yeah, and what other option could be besides the separation of concept, or giving the more option, more flexibility? Okay, so I will tell you, for example, exactly once delivery, how to assume that, how to achieve that, or handle, or for example, checkpointing. So if we go, I will open different sample. This one is not using projections, MongoDB, but it's using Postgres. And here I have a bit different logic. So I still have subscribe to all. It looks similar, but here I'm not passing the store checkpoint. Why am I not doing that? Because I have, let me find it. Yep. So what I can do here, because I have the storage and database, so relational database that is handling the transaction, then I could run potentially, if I want to, everything, all the updates for the specific events within the same transaction. And what's more, I can also try to store checkpoints in the same transactions. So if I have table, if I'm using the relational database, then typically for checkpoints, I would have a specific relational table. Then if I'm doing such, and if I have like, insert or update and have this position stored as a column, then I could place here a unique constraint and handle idempotency and exactly once delivery globally by that. Because what I'm doing here is I'm wrapping the handling, creating the transaction around all the handlers, and also around storing checkpoint in Postgres. So then if, for example, we try to update twice, and then we are storing the checkpoint, and we have unique constraint on checkpoint, then we could, if we get exception around unique constraint on the checkpoints table, then we could just ignore this processing and move forward. So this is an example how we could handle globally, like the globally the checkpointing without the need to call it to keep it in the specific documents, as I will show you.
I have a question about that.
Yep.
If you don't mind. So say that you have multiple transactions you're committing to Postgres for this event. So it's a many-to-one relationship, and I get that. But this second time that the event comes through to commit those transactions that are already committed, and this is really an outlier, maybe too far of an outlier, but what if one of those many in that initial pass of those transactions actually didn't commit and it got backed out? Therefore, would the event not actually be committed, and therefore the second time through would actually go and do that two-phase pass into the transactional store?
Yeah, that's a good question, because the thing that I didn't tell is that subscriptions are going sequentially, one by one, with events. So in subscriptions, at least in Event Store DB, in Kafka, in Marten, you have this guarantee that you will be getting order events in the order as they were appended. So if we are sharding our processing, so we don't have multiple subscriptions that are updating the same read models. See, I'm using as a key of this storage the subscription ID. Then if we sharded that and we don't compete for those resources, then we shouldn't have the situation when there is some hanging transaction in the middle of processing of the next event. Because if this transaction is hanging, then we won't go to the next event because we won't acknowledge this current event that we are processing.
Right. Thank you so much. That's helpful.
Any other questions? So this is also how more or less Marten handles that internally. So when we are, let's say that we are appending new event and we have here the transaction, right? And so if we had method like append event, then we could run the append logic here and then find all the handlers that we have for the specific event and update those tables within the same transaction. So that's how Marten is capable of handling multiple projections within the same transaction as a pending event. Okay, so let's get back to Mongo. So this is really simple code. We are subscribing from specific position. Then once we get event, then we are trying to run through the handlers and handle this event. And then we are storing checkpoint. And for example, Kafka is handling that internally, but we need to call ACK. So this ACK that we are calling is in fact storing the checkpoint internally in Kafka. In Marten, we don't need to do it. It's hidden, but it's done more or less in a similar way because there is events progression table. So all of the tooling, the messaging tooling are using logically a similar pattern to handle subscriptions. And Event Store DB has also persistent subscriptions, and persistent subscription can handle checkpointing on its own, but there is an issue with persistent subscriptions because they don't guarantee ordering. So they are not recommended to be used for read models, because in read models, we typically would like to have this global ordering. But of course, we can handle that and message that on our projection logic, but still, I would not recommend persistent subscription for that part, especially that persistent subscriptions are running on the leader node and only on leader node, so they are also degrading performance. But let's get back to our projections. So let's have a look on the simplest projections that we can imagine. So this is projecting to shopping cart details, and shopping cart details are looking like that. So it's like a flattened information about the shopping cart. So we have the client ID, status, list of products, and some metadata when it was open, whether it was confirmed, and some revision. And again, as we are handling this, each of this stream, so each shopping cart will get its own read model, then we can use this revision, so this numbering within the specific stream. Because this revision, in Martin it's called version, each event store unfortunately is naming that differently, but we can, once as we are updating our read model, then store also in the read model the position of which we were, of the last event that we processed. So this position can be used in many things, for example, also for optimistic concurrency. I will paste the link to the blog later on, but this time we will be using that to handle idempotency. Let's just scroll to that. And this is a simple logic how to verify whether we would like to know whether this projection is capable of handling the specific event. So here we are saying that if it is a shopping cart event, so it is one of the types of the shopping cart event. So we are just validating the event type. Then if it is, then please proceed. And if it's not, then just ignore it. And I'm also returning the update result, which is the MongoDB result of the operation. And we'll see later why do I need that. And here we are getting the event, and event contains like an event payload. And also this resolved event, which is the event store DB type, contains metadata like revision, position, etc. And then we need to get also the shopping cart collection because we will be doing operation on this collection. And as in the end, run the specific projection logic. So we are passing the collection. So in traditional approach, it would be probably table or some client event and the stream revision. And then we don't need to do like such a huge switch. We could use each projection to separate method. It doesn't matter much. It's about the personal preference. But what we need to do is, depending on the specific event type, run a specific business logic. And in general, the recommendation is that this projection logic should be idempotent. There are multiple ways how we could handle idempotency, but the most popular and the one that I would like to show you is by using the stream revision. So as you can see, we are taking the stream revision, which is, again, the position of the event within the specific stream. And every time we update, then we are also storing this revision. See, yeah. So I'm incrementing revision, but probably I should just assign it here instead of incrementing. I can increment it because we won't have gaps, but technically I should probably do something like that. It would be more correct and safer. Yeah, so something like that. And then I have also additional logic that let me go through it. So for the first thing, what I'm saying, and projections in general should be really close to our storage, and it shouldn't be like the lowest common denominator. And MongoDB is probably in this case like the database that requires the most amount of work from us, because it has eventual consistency on reads. It doesn't give you the guarantee like read your own writes. It doesn't have the built-in optimistic concurrency. You can achieve that, but you need to do it manually. And it doesn't have also stuff like Elasticsearch has. So being able to, for example, provide external version, but we will go to that later. So here, in the shopping cart open, I'm saying that I would like to append, to upsert this document, but I only want to run this assignment on insert. So this is the weird or great, depending on your preferences, syntax from Mongo. But what it does, it says that this code will be only run on insert. So if it's update, then it won't do anything, and it will just ignore the next update. So this is a way of handling idempotency. See, I'm not using here the condition that I have later on about expected version, because some type of operations can be just handled that we can just leave them as it is and allow to call it more than once, and nothing wrong will happen from that. And here, this logic will even return that nothing was updated. So it won't just provide an empty update. For product item added to shopping cart, then we need to do a bit more. So besides the ID, we need to also provide the expected revision. And this here, we are getting the benefit of having the gapless numbering. So it's easier, because we know that from the previous update should be the current event revision -1. So we can just use like the equality here, because we know precisely what was the previous version. Because if we handled this event and now we are on number 3, then the previous one has to be 2. Because we won't have any gaps. So is it clear, or should I explain this part around revision?
Might need a little bit more.
Mm-hmm. So maybe could you tell me what's the biggest confusion of what I said?
I think, one thing actually, while I've got you, is do you by any chance have a corresponding sample that's in SQL or Postgres?
Yes.
Relational example. Okay, mm-hmm. Awesome. I'll hold my question until a little bit later.
Yeah, but let me try to show you how this is happening on the. Let me try to show that in the Miro board. Let's say that we have following stream. So So we open shopping cart, added twice stuff there, and in the end we confirm it. So here we will have a specific stream for the specific shopping cart, or it might be queue in messaging system or partition in Kafka. So, but still it needs to have some ID like shopping cart 1, 2, 3, right? And now we have each of this event will have the auto incremented number with which is the revision or version or whatever it's called or offset. So we will have this is having 1, 2, 3, 4. In even store DB is counting from 0, but nevertheless. Then we have this shopping cart view. And we are also storing here the information of what was the last event that was processed. So if we take the first event, then we won't have any read model. So on the first, when we are applying this one, then this will be storing the position from this event, right? So we will have some data field like this one. So client ID, pending status, empty product items, and revision. And then our subscription is on this event. So event number 2. Yeah. So when we are applying this event, then we are saying that because this numbering is gapless, then we can say that update this document only if it's update only if it's 2 minus 1, so 1. So if it is, so here we see that, okay, so this is the version from here, -1. So we should go ahead and update this one. And we are storing this revision from this event. And then if we get this event twice, and if we got it twice, then the next call will also say that update this document only if the version of this document is equal to -1, because we expect that the previous event that was handled was this one. So in this case, the second update will be just ignored because there is no document like that that has shopping cart ID that we specified here and the revision that is smaller than this one.
That makes total sense, and beautiful use of Miro on the fly. Thank you very much.
Thank you. Thank you. So yeah, so and as you see, I'm not using here any find one. So I'm trying to be optimized in a way that updates have better guarantees than reads. Because if I read this document, and I will have such example later on, then Mongo can lie to me. So even if I applied 2 and I read it, then it might be still, I might still get the stale data. So before the update, but we will get to that later. In SQL storage, it's a bit simpler in a way that we have stronger guarantees. And if we are preferring to use some ORM, then here is the logic for opening shopping cart. Then we are just calling insert or ignore. And we are also providing this stream revision. And we are also inserting new document. And then if we have this product item added, then we could also technically use ORM here and just append to nested collection. But if we'd like to run something that is more optimized, then we can run also the specific query and use some upsert statement, depending on like if exists, then insert. If it's not, then do update, etc. So in SQL, this is how technically this could be done. And but if we are using relational database, then as I showed before, it's totally fine to use such way. So store the checkpoint in the same transaction, then we are sure that that we won't have any idempotency issues here. Yeah, so the summary of that is to always try to use the, you know, stuff that is native to our read model. So not trying to make not trying to make the lowest common denominator, because if we have events, then for example in Mongo, this is really neat that you can use some atomic operation that will only update the specific document, the specific part of document. So for example, we can say that if we are having this, if we are having this document with the ID and expected version, then let's increase the quantity of the items. I'm doing here a trick that I'm also at first appending product item with 0 quantity and the price, because I'm a MongoDB noob and I wasn't able to find one liner with one update to do that, but probably someone more skilled with MongoDB could do it a bit better. So best is to not try to get the whole document and then update it, because it's less performant. And also in the tooling like MongoDB, Elastic, we might get stale data. So of course, then we can run retries if we have the stale data, but it's not perfect. So this is probably the most common way of handling idempotency, I think, and also kinda eventual consistency, because if we have those updates, then usually databases give us the much better guarantees than reads. For example, if we call Mongo and we say that we only want to update document with such ID and such revision, then it won't update document that is not with this ID and this revision. So if we got that the record was not updated, then we can run retry, define some retry policy. It's even recommended. I don't have it here, but we could do it like retry if not updated, and define some. The retry if not updated is my helper method. So retry if not updated is checking is asserting that some stuff was modified or upserted. It should be probably. But yeah. So the thing that is really important here is that we should somehow correlate the data from event with the ID of the read model that we would like to update. And here I'm doing that with the update one. But if we have a look on Marten, so tooling that has more stuff built in, then in Marten, we are either using, if we are using a single stream projection, like here, then Marten will assume that the read model ID will be the same as stream ID and try to at first get it and update it. So we have in Marten this round trip of at first retrieving document, updating it, and storing the next version. And in Marten, you have more stuff out of the box. So you can define the projection. And what you need to do is provide apply method that takes event and the document. And then you are defining how to update this document or returning the new version of this document. And then Marten will take this document and update it for you. There are also, of course, cross-stream aggregation projections. And for the cross-stream projections, we need to provide information how to correlate data from the event and with the read model ID. So here we are saying that we would like to, for this specific user group assignment, and user group assignment contain information about the user and all the groups that it was assigned to. Then we are saying that from user registered, then take the user ID and try to find out user group assignment with value of this user ID from this event. And for this event, then also try to use user ID. So the important thing is that we need to have somehow a way and some data both in read model and event to glue those information together. And this is getting quite tricky sometimes, because let's have a look on those events. So events in general should be rather granular. So here we are keeping only those informations that are needed. So we are trying to not repeat those informations. So if we have the first event, shopping cart opened, then we have the client ID. But this client ID won't change during the shopping cart lifetime. And that's why we don't have this client ID anymore in the follow-up events. So of course, we could add them here, but then it's kind of duplication. That doesn't have to be wrong, but it might be confusing even for us, for a future us, like, why do we have the client ID in product item removed? So we would need to think like, is it possible that client ID is also changing, or maybe some other person, like multiple users can access the shopping cart? And for me, events are kind of documentation. So it's best not to try to put too much into them, but still, if that helps and if that works to, for example, make the correlation on the read models much easier, then maybe it's worth it. Or the other way is that, for example, some modules or some functionalities are not interested in all those information, like whether something was added, removed, etc. Then maybe we could make just the final event to contain like the summary of what has happened, so the final result. So this event would be a bit thicker than in theory it should be made, but maybe it's worth it to just keep it in the shopping cart confirmed. So for example, add here all the information about the client ID and all the product items. Keep it like that. So maybe that's worth it. So we need to always, when we are designing events, we need to start, of course, from the business logic, but then think also about the other usages. So think about like how this will be handled and whether we cannot design our events in a way that it will be easier for us to handle idempotency, to correlate information, etc. And of course, we can also have a projection, as I mentioned, that will be publishing other events. So
I have
if
a question about that.
Yep.
I don't mind. The idea of having all the repeated information in this shopping cart confirmed event sounds like you're basically just putting a snapshot in your event store.
It's a similar, but it's not precisely snapshot. It's a summary event. I mean, it's anti-pattern called a pattern, but I mean, it looks similar, but it's not a snapshot because snapshot is you are taking your structure of the aggregate, so your right model, and you are just snapshotting it. So like doing a photo of it. So it has exactly the same structure as the as your business logic, but the shopping cart confirmed, if we do it like I showed here, then of course it looks here kind of similar, but it only contains information that are needed. So it might be smaller amount of data that we have in our right model, plus it also gathers a specific business information so that shopping cart was confirmed. So it's not like a technical snapshot made for optimization, but it's a business information informing also the others about what has happened.
So in the case of choosing whether to read from the snapshot or going through the streams and looking for all shopping cart confirmed,
Mm-hmm.
what would be the point of salience between making one choice versus the other?
Because especially if you are using event sourcing, let me show you. Then, for example, for your business, your right model can have even less information than this event. This is my shopping cart because I put only in my entity for my business logic, only information that I need for it. Like I don't have any if for opened ad. I don't have any if around client ID, even around shopping cart ID. Then I just don't put it here because I'm rebuilding the state each time from memory. So, and product items here is just a map of the product ID, quantity, and price. So it's the right model structures. What I'm trying to say is that right model structure can be much different than information that we need to publish for the event. And the fact that we have this event is a bit thicker is that, like, for example, the financial module, it doesn't care about how the shopping cart and what was the history of the decision making that user was doing. It only cares about what's the final decision of that user. So that's why it's more about completion than having all information. So it's like, I know it's a gray matter, but technically it's the most important thing is summary event is still a business event, and it might not contain all the information about
Got it. Thank you. Yeah, that's helpful. Thank you so much.
On that note, at the risk of going onto a tangent, but if you chose to use a thicker event, like for these terminal style events, Could it
Mhm.
also be argued that if you had downstream services that are interested in those events, that it might be useful for them to put those onto a queue or something like that?
Mhm. Yeah, so typically what I would do is I would keep this event theme, but I would do, let's revert. I would create another let's call it external. I don't have better name right now. And I would define all the events that I would like to have published outside of my business module. Because if I'm publishing those events to my read model, then probably my read models will understand and will know about all of the information that I have in those events and will understand them. But if I try to publish all those granular events to some external queue, and I would ask all the other modules to have to listen for all those events, then it would be like a leaking abstraction, because they would need to understand the whole flow while they don't care and should not care about this whole flow. So I would typically have some projection that would take my event, load this additional data. It might be from other events or from read model, and then enrich this shopping cart confirm, adding this additional data that other modules need. And this is the event that I would probably publish to some external queue. And if we are using like Kafka, for example, then I would have different topic for my internal module needs and different for external. So external modules do not need to listen for all the events that I'm creating.
That's an awesome answer. Thank you so much.
Thanks. There is an
that's
article.
really very helpful to me too. That was a great question. Thanks for that.
Thanks. Yeah, that was a question that I counted to get. So great that you asked that. Yeah, there is an article on my blog around that events should be as small as possible, but not smaller. And we should always think about the private API and public API because events are our API, kinda.
I have another question.
Yep.
Or it's two questions. As you said, one thing is you can apply one event to multiple streams, and it's related to Martin. So when I'm saying I have a scenario where I'm having an event, employee gets added to a team, for example, or assigned to a team. So I have this one event, and I'm saying, okay, I put it into the stream for the employee and for the team. So Martin is ensuring it's getting the right ideas in the context of each stream, even if I have the same instance of the event. Okay, so that's one. And another one is related to this scenario: how much data should be contained within the event. Is if I'm saying I assign an employee to a team, in general, I would just need team ID and employee ID.
Yes.
But I want to show some data on the side of the employer, which should show the team name, for example, and on the other side, in the other projection, I would show the employee name. So I'm putting more information and duplicated information into this event. So with Martin, I could also inject a query session and update the projection with by querying the data. Would you? So I guess it's a classical depends answer in general, but would you lean more towards the usage of the query session inside the projections, or would you enrich the events here in that particular scenario?
Yeah, there is no golden rule here,
Yeah.
more like a thumb rule. So even here, I'm doing a bit more than maybe someone would do. So for example, in the product item added, then I'm, besides keeping information about the product ID and quantity, I'm also keeping information about price. In theory, and that's highly dependent on the business logic, so we always need to fall back to how our process looks like. But here, I'm assuming that I would like to freeze the product price. So even if the product price has changed, then I wouldn't like to sell, for example, for a higher price to user that this person already like selected. Maybe it could be like when they are adding, then we don't need to froze it, but when they confirmed, then we might need to froze it. And some people would say that, okay, but probably for pricing, there will be additional module, different bounded context, and we are not the source of truth here. So, but, and we can have some race condition, but then we need to find like, we need to select our trade-off and find out how far we would like to go in checking the consistency, because usually the super strong consistency requirements are not correct. And regarding your case, then there are different possibilities. Like, let's say that we have 2 streams. Okay. Like team created, team name changed, and we also have the user assignment. So user created, yeah. So if we have such events, then those two are different streams. And they have their own numbering, so 1, 2, 1, 2. And probably they also somewhere in the global information. So for example, it might be that we created this user. After the team was created, then team name changed and the user was assigned to the team. And this is the order in the global log. And so if we try, and we have, for example, let's say 2 read models. One is the user assignment, and the other is team details. And if we'd like to, in the user assignment, besides the information that user was assigned to this one, to this team, and to have more than just IDs, like we would like, for example, to have user ID, username, teams, which would be like a team ID and team name, right?
Yeah.
So then it depends on how our projection processing is being made, because if we have a single projection that is going event by event always, then we can assume that we already know here that, for example, team name changed, or if we get this team name changed, then we will update everything, and we can, while processing, for example, this event, we can query the team details and store the team name here. But if we have two projections, separate projections, this is one projection and this is the other one, and they are run in parallel, then we don't know which one will be faster. Because we have only guarantee of ordering within this specific subscription or projection. So this one, if it's updating the team details, then it will take all the events from the teams, and this one will take all the events from users. And if they are running parallel, then we don't know. They might be run like that. They might be run like that. So within this specific subscription, the ordering is guaranteed. But if we have it like that, then we don't have it. So of course, we can have a single projection or single subscription that will be updating all of them, or as in Marten, all of the projections that are made synchronously, but then we are taking the trade-off around performance because we cannot parallelize that. And in Marten, asynchronous projections are by default parallelized. So you cannot assume that one of them will be run earlier than the other.
Okay. So it would be better to enrich the event.
Yeah, we can enrich event. We can maybe, in Marten, joins are not great, but in traditional approach, maybe we can keep the relational data and then do the joins on the fly while we are making query. It's not perfect, but maybe it's good enough.
Okay.
Or there is another way that we can run the projection that will be subscribing for those events and take both events from here and from here. So use all the events. So grouping those two together. So the downside is that we will have more events to process, but maybe it's good enough. Or we could just replicate it to some specific stream.
Okay. What I was thinking of is using multi-stream aggregation, but they have to be of the same type. You can't have a multi-stream aggregation for one is employee and one is team. It has always to be of the same type, right?
No, you can use from different types of streams.
Oh, okay, so that would be a solution as well somehow.
Yep. And the other downside is that if we would like to do a rebuild and we have like one subscription for all those events, then if we are, for example, we were at this position, but we decided that, okay, no, we would like to clear our read models and start it from scratch, then it will need to go through all the events. And here, all the events will be processed more than once and all the projections. And if we have separate projections, then we can run precise projection rebuild for the specific projection. And the rebuild in general works like that. So as the projections are predictable, because we taking the set of events and then applying them one by one, then in theory, if something went wrong in our logic, then we could do an in-place rebuild, like erasing the state, saying that currently we would like to start either from scratch or last known good position, and then reapply all the events. But this is a no-go if we cannot have like a zero. We need to have a zero downtime, and if we would like to have a zero downtime, so blue-green rebuild, then typically we would need to set up in parallel the next version of this document, keep the old one and do the queries till the old one, and then apply the events one by one to the new one. And once we catch up, or we are close to being catch up, then we can say that, okay, we are then making queries to the new model. Unfortunately, in Marten, blue-green deployment is challenging right now. We don't have out-of-the-box solution for that.
Okay.
And here is the example of multi-stream projection. And the multi-stream projection, but here is on the same type. So we would like to get the total quality, so quantity of all the products that some client bought so far, the total amount, so how much money does this client spend, and of course, and here we are using position, because we might get events from multiple streams, so we cannot base on revision, because revision is only acceptable for the specific stream. So we are using the global position instead to handle idempotency checks. And we also have this pending that I will show you again later on, how that can help without enriching events. Because here, the ID of this shopping cart history will be the client ID. And as you saw, we don't have this client ID in events like product item added, product item removed, etc. So that's why I created this pending shopping cart, and we can use this nested property to accumulate the pending information. So this will be used for queries. So we will be only querying for those two fields. It won't be publicly exposed, but we can have like a accumulator that will be containing like a shopping cart ID, a pending, so not confirmed and not canceled shopping cart with its quantity and amount. And once we confirmed, then we could increase this quantity and total amount from those number from the pending shopping cart. So let's see how this could be done. So here, if we are getting the shopping cart opened, then if there was no summary for this client, then let's append a dummy one. And if it is, then as I explained before, it will be just ignored because this is set on insert. And then I'm not passing the exact position, but I'm saying that it has to be, the position of this document has to be smaller than the event position, because I cannot use this as I did with the shopping cart detail. I cannot assume that the previously used event had the stream revision -1. I cannot assume that for position, because position can have gaps. It might be that this event has position 200 and the previous has 100. And in event store DB, this position is even less understandable because it references to the logical byte position in the disk. So it might be some arbitrary big number. In Marten, it's generated based on the Postgres sequence, but Postgres sequence can also have gaps. So, but we have the guarantee of the ordering within this processing. So we can say that, okay, we don't know the precise number, but we can assume that the previous one was smaller than this one because this is unique. So previous was smaller. So we can do such query. And then here we are just, if we got the shopping cart opened, then we are appending this pending information about the shopping cart. And because of that, we can use it to query this client shopping cart history. See, in the product item added to shopping cart, we don't have client ID, but that's fine because we have this additional storage that is maintaining information about the shopping cart ID. So if we had the traditional relational database and relational table, then this pending could be just another table that has the foreign key. And here we could join those information to find which exact record we would need to update. Is it clear, or should I explain it more? I know that it's 1 hour and a half already, but yeah, I can try to at least shed some light.
Just want to say thanks for the answer so far.
Yeah, I'm glad you brought this up with the global position and using that. That was a question I had too, so I appreciate it.
Okay. So yeah, in general, we are replacing the stream revision with the position, and we are using smaller. And not in all databases we need to do it. Elasticsearch has concept of external version, and if we provide this external version, then we are telling Elasticsearch that, don't worry, I handle that, I know what I'm doing, and Elastic will ignore the update or throw exception depending on our strategy if it was already applied. So if the version on the document is smaller than we have here. So, but tooling like Marten, you have it out of the box. You don't need to think about that. But if you are using other, like even StoreDB or Kafka or Rabbit, then you need to think about that. And this is the potential way of handling that. So Alex, for you, you could, in theory, have some additional also information here and accumulate that inside the document, like I did here, because in Marten, you could do the same.
Yeah, okay. We'll play around with it. Thanks.
Yeah, the only downside is that currently in Marten, we need to load the whole document. We cannot, like in Mongo, load just part of that. So you will have a small performance penalty, but then you can select, you can filter on and return only those information that you need. Okay.
Yeah, I guess I will come back to you when I'm playing around with it.
Sure.
Of this meeting. Okay. Okay, great. Thanks.
Thanks. So I promise you to show how we could test it. And so let's do it. Sorry that it's taking a bit longer than I promised. Again, I'm not good at estimation, it seems. Surprise. So those are tests that I wrote to show you how you could test projections and how you can build a quite simple testing tooling to run projections without the need to run the messaging platform. So what we are doing here, maybe let's go to on product added, then we would like to test, like to say that previously we get opened event, so shopping cart opened event, and now I would like to verify that after I run through my projection the product item added, then after that the result will be documented with such ID and with such payload. So this is the test setup. So for example, for removed, then we would have like some shopping cart was opened, then we added new document, and now, so given product shopping cart with some product item added, when we are applying the product item removed, then the result state of this document looks like that. Is this pattern clear before I go to how I implemented that? It's like a behavior-driven development. So given some set of events that we already ran on projection, so we assume that we have tests for those scenarios and we have them above. After I run this when method, then I will have the result document. In theory, instead of passing a sequence of event, I could put here also the current state of document. That could be also okay. Yay or nay?
Yep, definitely.
Okay.
Yes.
So let's.
Yep. When then is this a library or?
Yeah, I will show you.
Oh.
So this is a super library that brings you the specification. So it's like a specification pattern. So you have the shopping cart event. So we are saying that we will be checking how application of the shopping cart event will impact the read model, so shopping cart details. And then we need to provide the shopping cart collection and the projection logic, because this will be run internally through this test. And this magical library is implemented by me just for this webinar purposes. So-called library. I will explain you. So again, this is the type definition. So if someone is not a TypeScript developer, then this might look a bit weird. But what I'm saying is that I'm defining the specification that I have some set of events, sequence of events that were appended before I would like to append more events. So in when I'm providing those events, that projection I would like to verify. And after that, I have methods like then, which compare me the expected doc with existing one. We can verify if document was not updated to check the idempotency. And also we can check whether it was updated the number of times we expect. So this is our type definition for our specification. And how to implement that. So in languages like C# and Java, this will be probably a bit more lines than that, but maybe it's better. So I'm defining a method for, and I'm saying that this specification is for this collection of documents and this projection logic. So it can be either the logic that you saw here, so for the shopping cart details, or for the shopping cart history. So we will pass this method here. See, I'm passing the collection and this projection logic. And this is what for method is doing. And for method is returning me a method. Again, method from the method inception, but essentially it's just a method that takes events. So this is this given method, it's this method. And I'm returning object that has this when method. So by that, I'm shaping the object structure like you see here. So given returning me an object with when, and when is returning me object with thens. So it's like a fluent syntax. And in the end, once I have this when method, then see I'm returning just a set of thens so someone can verify. And then method, what it does, it tries to verify whether the document was, that we have a number of events that we assume. So in this case, the number that we provided if in end, and also doing some assertion that the document after update is the same as expected. So let's see how this engine is going. So I have the given set of events. So given, to go to the test, given are those events from the test setup. So for example, for product item added, in given we will have just one event like opened, or if we are trying to test removed, then we will have opened and removed. So this is our setup. And we are joining this setup with the events from when, because technically for all of those events, we would like to run the projection logic. So this is the for each. For each of all the events that we provided, let's ignore it for a moment. I would like to run the projection logic. And after I run the projection logic, I would like to verify that all the all the rights were acknowledged. So MongoDB got them, and also we would like to verify, for example, whether the total changes count was as we provided. So we are just taking the result from the Mongo update. So that's also the reason why we are returning the update result from Mongo. And then we are just, summing up all the updates that were made for all of those events. And what's more, what I need to have is that I would like to also be able to provide a position or revision to be able to verify the, at first, verify the idempotency. And also, I need this position to verify the assert updated. Because as I mentioned MongoDB has eventual consistency. So I'm filtering to get the object. I need to provide, besides ID of the expected, I need to also provide either revision or position. So I need to tell that I would like to find object for this specific ID with this specific revision or position. And quite often I need to retry that because of eventual consistency. And once I get the result, then I can compare it with the expected document that I provided. So that's why I need to pass the position. And to show you this idempotency check is here. So for example, maybe let's go here. So see, I'm adding those 3 events: opened, product item added, removed, and then I'm trying to apply the same event with the same revision as this one. So as I mentioned, the event store DB is counting from 0, so it's 0, 1, 2. So I'm saying that I'm trying to reapply the same event that I done here. And that's the reason why I need to have this revision. But because I wouldn't like to need to provide those revisions and position everywhere, then I can also provide the regular event. And in this for each, I have this auto-incremented position if I didn't provide the position explicitly. So then the first event will get the 0 position or revision. So this is here. And the next one will get the 1, 2, 3, 4, and so on and so forth. So what I need to explain, because I assume that this might be not totally clear. Should I try to explain it again?
Well, I just came back into the meeting after dropping out for another touch base, so I would love it if you went through it again, but I don't know if everyone else wants that.
I would love if you would build an event store for Node.js where I could go back to TypeScript.
Yeah. Yeah. So in general, again, we have the test that is specifying that given set of events, so those are events that we assume that were already applied. And we have when, where we can also provide more than one event, but here I'm passing just a single one. So after we applied, in general, all of those events, because we will be running the same projection logic that we passed here in the specification, then we should get back with the following document. So it's just a simple check. And if we would like to check the idempotency, then we can also do it by claiming that, see, I got here this set of events, and I would like to reapply again the last event with the same revision. So we will be verifying the logic that we have here. So, providing the stream revision and all that stuff that we already discussed. So this checks by expected revision. So I'm not saying that you need to write such testing tooling, but it's not so hard to do. And if we don't have like Mongo, but relational database, then it's even easier to do it. And the main thing about testing projections is that you don't need to have a connection to the real messaging tooling. You might not need to do the full end-to-end test. You might still do them, but most of the stuff and edge cases can be handled by such integration tests. And this integration test is not so long. I'm not sure if probably it has something about 100 lines. In C# or Java, it would be a bit more, but it should be also transferable. So this is how you can test projection logic. You could, in theory, test it with the unit tests if you have just object mapping, but still, I would recommend to rather use the integration test, because especially if you are using the native tooling and native storage libraries, then it's better to make sure, because this syntax is so unusual, then it's easy to make some mistake even with TypeScript. Okay, so in general, that was mostly it. I already took 15 minutes longer. So maybe, do you have some questions? I could try to answer a few of them.
This is Houston. I have a quick question about what you just showed, and I'm just kind of processing it in my head a little bit. Are you, in essence, actually proffering a specific event stream in that test, kind of like building a mock and then testing against the projection that it generates?
No, I'm not mocking anything. The only thing that I'm mocking, kinda, is that I'm not requiring to use the messaging tooling. so in this, sorry. Yeah, so I'm passing the events, and they are not, and they are, nothing is done with them until you call this then method. And after that, for each of the events that you provided, I'm running the real projection logic against the MongoDB. So I'm doing the for each of this event, run this projection logic that we are testing. And then I'm checking the end result of that.
Right. Got it. Thank you.
Yeah, so the other option would be to, instead of passing events here, then, for example, passing the initial doc, right? So then we would apply those, we would insert this initial doc, and then we would run this projection logic on top of it. So that's also fine to do. It will be probably even more isolated, but then you would need to be sure that what you provided there is something that you can get from the projections. So maybe it's useful to have both types of tests.
Thanks for that.
Yeah. And maybe one more thing. Feel free to interrupt me or ask me a question if you have such. But if not, then in the meantime, as you are thinking about some question, then I will show you, if you'd like to play with that on your own. It's on my repo. I will paste the link on Discord. So I'm running the Docker here. And one thing that I didn't show you that I have in my tests. So I'm using the test containers in those tests. It's a useful library. It's in .NET, in Java. It's originating from Java, as I recall. It is, but it's right now for majority of the most popular testing tooling. So you can have this test containers and set up your own container. Like I have, for example, MongoDB container. So I'm saying which exact image I would like to use. I can provide some additional environment, some port, and then I can provide such methods like get Mongo client with the connection string that is generated from this Docker. And when I have it, and I can also reuse those Dockers. And when I have it, then I can use this Docker container here, and just even for each test, in theory, I could run a separate Docker instance. That wouldn't be probably too performant, so I'm reusing, but it's also a nice way because they should, at least in theory, gracefully clean up after themselves. So it's a nice way to use automated way. If you run this Docker container start, then it will be automatically starting and shutting down those containers for you. So it's a useful library for integration testing like that. Okay, so I have Docker started, and I have Postman collection. It's in the repo also. So you could, for example, open shopping cart. I'm probably not running the server. It is. Okay. And then you can verify that it was already got. So see, we got some read model. Then we can append some new data, like new product, and verify that it was already appended. And see, we have new product item. That's cool. And I also, if you run the Docker Compose from this project file, then you will get both event store UI. So see, those are streams that I created. This is the one that I have even confirmed. And there is also the Mongo UI, the simple Mongo UI. And if there is a database test, and see, those are checkpoints. So this is how our subscription would look like. It has just subscription ID and position. And it also has this, let me delete the, okay. It has this information about those read models. So for example, shopping cart details, see, those are those information. One is confirmed, different revision, etc. And the final thing before we close up is how you could restart and rebuild projections. Let me delete all read models for now. Let's delete this one. Why is it not deleting? I have space. See, I deleted all the details. And then if you'd like to rebuild it, then you could either delete this whole collection, or you could just either delete this exact record, or we could try to update it to, for example, some position like 0. And once we do it, then we could restart our application, even from debug. Let's open it. Okay, starting. Let's give it a bit more time. Yeah, it should be. And let's have a look on our test database. Yeah, we already have the shopping cart details. I should remove this debug breakpoints. See, and now we have this, all the shopping carts that we had before. At least we should get them soon. Might be that my breakpoint broke something, as always in the presentation. But the last thing that I wanted to show you is that if we would like to do the blue-green deployment, then we could start, or maybe start additional instance or stop our server. And in MongoDB, it's quite easy because we could add to the shopping cart collection just a version suffix. And if we again deleted the checkpoint here, so we don't have any checkpoint, then we will be reprocessing all the events. Let's start it again. And let's assume that the previous one was already running, and then we are spinning up the new version that is claiming that this will be our new version of the read model. And once it started, let's give it, okay. And then and see, we already we have this previous version, so the old version of our services can still query this old version, but we already have this also new one, which obviously has some error that I will need to investigate, but that's in theory how you could do the blue-green deployment. So change the checkpoint or delete the checkpoint and target to some new database, either collection in Mongo or new schema or new table in relational database. And that's also how you can play with this code on your own if you'd like to after the webinar. Okay, so sorry for taking you longer than I promised, but I hope that at least you learned a bit more about some challenges and how to solve them around projections. So it's not that it's really scary, in my opinion, after you know those patterns and you play with them, like patterns like checkpointing, like using position in the target read models can take you really far. And also there is a lot of tooling that is less rawer than this combination that I show you, but I wanted to show you how that works in a nutshell, because all the other messaging tooling and databases can either be a bit easier to use or have more stuff out of the box, but the general logic and the general usage looks the same. So yeah, so thank you for staying such long with me and for joining the call, and for those that are rewatching. I will be also happy to get more feedback from you, so feel free to ask and share the even constructive criticism. I'm happy to take it. So yeah, that's all from me. Thank you.
Great session. Thanks.
Thank you.
That was really great. Thank you for all the info. This has been really helpful.
Thank you. I will try to publish the video probably tomorrow, maybe today, but probably tomorrow, and we'll send the link as always as a follow-up with also some additional materials. But link to repo I will already paste on Discord. Okay, so thank you a lot. Have a great day or a great evening, and talk to you next time.